Black holes have been a big problem in physics. For decades, scientists have been mystified about what happens to stuff that falls into a black hole. The quandary is called the black hole information paradox, and it has stopped physics in its tracks. But in recent years, scientists have made a breakthrough that may finally solve the puzzle and begin to show how black holes really work. To understand the paradox, we have to go back to Stephen Hawking's big idea. Just like a puddle of water out in the sun, a black hole will slowly shrink, particle by particle, until nothing is left at all. His discovery originated in quantum physics, which shows us that empty space isn't actually empty. Instead, pairs of so-called virtual particles continuously arise out of the vacuum. These pairs usually stay together, except for the unlucky few that arise on either side of a black hole's boundary, its event horizon. In that case, one member of the pair can get trapped within the horizon, while the other carries energy away. Eventually, this escaping energy shrivels the black hole down to nothing. The only problem with this scenario is that if black holes can be destroyed, then so can all the information about what fell into them. That seems to break a fundamental law of physics, which says that information can never be destroyed. What gives? For nearly 50 years, physicists were stumped by this problem. But in the past few years, a unique solution has revealed itself: wormholes. Wormholes are theoretical bridges in space-time that connect two distant spots through a shortcut. Wormholes sound like something out of a science fiction movie, but they are real predictions of Einstein's general theory of relativity. Recently, a new breakthrough on black holes happened when scientists considered the possibility that the inside of a black hole could be connected to the inside of another black hole via a wormhole. Such a connection would be rare, but it's theoretically possible, and according to the rules of quantum physics, everything that can happen does happen. A particle doesn't simply travel along one particular path from point A to point B. It takes all of them simultaneously. Wild, but true. The same thing seems to be the case for black holes. All of the possible weird configurations of spacetime that could occur within them, including wormholes, do occur. When physicists added wormholes to the picture, a strange thing happened. Information didn't seem to be completely destroyed anymore. Instead, the interiors of black holes seem to contain special areas deep inside, called islands. These islands are part of the black holes, but also not. In a weird way, they're both inside and outside the black holes, as if they are part of the escaping radiation that is depleting the black holes over time. And as they escape, the information within them escapes too. These new ideas are pretty confounding, even to physicists, who are discovering that the cosmos and the nature of our reality are even weirder than we could have ever imagined.